Okay, Assalamualaikum and hi everyone. Today we are going to learn a new subtopic that is 7.1 acids and bases. Alright, so I think you are very familiar with this lemon and soap. So between these two things, right, which one is referred to the acid and which one is the base? Okay, so as we already know that lemon contain high amount of citric acid. Okay, whereas for a soap is a combination of a weak acid, fatty acid, and a strong base, which result in what is known as alkali salt or a salt that is basic on the pH scale. Right? So from lemon in your kitchen to the soap in your shower, acid and bases are everywhere. But what does it mean to say that something is acidic or basic? So in order to answer this question, we need to examine some of the theories describing acid and base. So in this discussion, right, we will focus on the three theories of acids and bases. Okay, but before that, we take a look at what we are going to learn for the learning outcome. For the first 1 hour, we are going to discuss about definition of acid and base according to arrhenius, Bronsted-Lowry, and Lewis theories. And then second, deduce conjugate acid and conjugate base according to the Bronsted-Lowry theory. Okay, define strong acid and strong base, weak acid and weak base, pH and pOH. And then relate pH and pOH to the ionic product of water, Kw at 25 degrees of Celsius. As for the other objective, we will cover later. Alright. Alright. So now these are the subtopic that you are going to learn today. Alright. So we take a look at the first acid-base definition according to Arrhenius equation. Alright. So the Arrhenius theory was originally proposed by the Swedish chemist Svante August Arrhenius in 1884. He suggested classifying certain compounds as acid or bases based on what kind of ions form when the compound was added to water. Right, so according to Arrhenius theory, acid is a substance that dissociates in aqueous solution to produce hydroxide ion, so H plus ion, or hydronium H3O plus ion in aqueous solution. For example, like HCl solution, when it's dissociate, it will produce H plus ion and Cl minus ion. So that's why we consider HCl is an acid. Okay, while base according to Arrhenius theory is a substance that dissociate in aqueous solution to produce hydroxide ion, OH minus ion. For example, like sodium hydroxide solution, when it dissociate, it will produce sodium ion and OH minus ion. So because of that, sodium hydroxide is considered as a base. Okay, alright. Okay, next second theories is Bronsted-Lowry acid-base definition. Okay, in 1923, right, so this Johannes Nicholas Bronsted and Thomas Martin Lowry from Denmark and England published the same theory on how acid and bases solution behave. Okay, according to Bronsted-Lowry, so combination of both theory, okay, acid is a substance that can donate a proton to another substance. Acid is also known as a proton donor. According to this theory, base is a substance that can accept a proton, H plus, from another substance. So we can conclude that a base is a proton acceptor. Okay, these two scientists came up with this theory independently and relatively at the same time. So the theory has both of their name. Okay, so that's why the theory become Bronsted-Lowry theory. Okay, for example, like an acid. So let's say I have HCl here, right? So dissociate in water. So it would become H3O+, which means water, it has a lone pair. It will accept a proton from HCl. So meaning that HCl here, it donate a proton to H2O and become H3O+ and Cl- ion. So therefore, because of that, HCl is an acid. Okay. Whereas since H2O here, it accepts a proton to become H2O+, so H2O react as a base. Okay, so these are the illustration. Okay, and then for example, like ammonia dissociate in water. Okay, so it will produce NH4+ and OH-. So since ammonia, nitrogen has a lone pair, so it can accept a proton from H2O, whereas H2O donate a proton to ammonia. So because of that, NH3 ammonia is a base, whereas water is referred to the acid. So from these two examples, so we can see that water can react as an acid or it can also react as a base. Depends on the other reactant. So next theory is about Lewis acid-base definition. Okay, so the Lewis theory was introduced in 1923 by American chemist, that is Gilbert Newton Lewis, in which acid is a substance that is referred to atoms, ion or molecule that can accept a pair of electrons to form a coordinate covalent bond. Whereas base is a substance that can donate a pair of electrons to form a coordinate covalent bond. So these are the example. Okay, the first example here is BF3 and AlCl3. So still remember about incomplete octet. Okay, so for the case incomplete octet, okay, so we have 3 elements. Okay, that is referred to beryllium, boron, and aluminium. Alright. Okay, since boron and aluminium have less electron, so it can accept a pair of electron in order to form coordinate covalent bond. So that's why BF3 and AlCl3 is an acid. But another example is referred to the cation. Cation has less electron. Okay, electron deficient species. So that's why cation can accept a pair of electron. Okay. Alright, so as for the base, alright, so for example, like we take a look at ammonia. So ammonia, nitrogen have lone pair electron. Okay, and one more thing is this one is alcohol. Okay, alcohol also at the oxygen atom have lone pair. So that's why ammonia and alcohol, it can donate a pair of electron to form coordinate covalent bond. And then the other example is H2O. So H2O also have lone pair. Okay, so that's why can donate a pair of electron. As for the anion is electron-rich species. So it has more electron. So that's why it can donate a pair of electron. Okay, so we can conclude that for the acid, usually a compound that is under incomplete octet. Okay, and then cation. Okay, whereas for the base is usually the compound that has a lone pair and ion. And one more thing is under expanded octet. Okay, expanded octet, for example, like PCl5. So for the phosphorus, it has more than 8 electrons and therefore it can donate a pair of electrons. Review of all the definitions. So acid and base theory, so we have 3. Bronsted-Lowry theory, Arrhenius theory, and Lewis theory. Alright, so for the next chemical reactions, so we will use the Bronsted-Lowry definition. Alright, so now we move to the conjugate acid-base pair. Right, so we take a look at the definition. So conjugate acid can be defined that a species formed when a base accepts proton. Okay, whereas for the conjugate base is a species formed when an acid donate proton. Okay, we take a look at the example, right? So NH3 is paired with NH4 plus. So when compared with these two species, we can conclude that NH3 accept a proton to form NH4 plus. So therefore, this is a base. Product form that is referred to NH4 plus is referred to the conjugate acid. Whereas for the H2O here it's donate a proton to NH3. So therefore H2O is the acid and the product form that is referred to the OH minus ion is referred to the conjugate base. Okay, now, so we take a look at the second example which refer to this equation. Alright, so acetic acid, okay, pair it with its ion that is CH3COO minus. Acetic acid is an acid because it donates a proton. Okay, and the product form is what we call conjugate base. Whereas for the Cn minus, okay, so it accepts a proton from acetic acid. So therefore, Cn minus is a base. And the product form is a conjugate acid. Okay, keep in mind, H2O is amphoteric. Amphoteric here means it can react as an acid and also base. It depends on the other reactants. For example, like reaction A here. Alright, so HCl dissociate in water. Okay, therefore HCl, so it donate a proton. So therefore HCl is an acid. So donate proton to H2O. Since H2O have lone pair, so it can accept H plus. So because of that, H2O react as a base. Okay, for the reaction B, NH3 dissociate in water. Okay, because NH3 have lone pair on the nitrogen atom, so it can accept a proton from H2O. So whereas for the H2O here, donate a proton to nitrogen. So H2O react as an acid. Okay, now we take a look at the first example here. That is referred to this question based on arrhenius theory. Alright. Okay, so identify whether these compound are base, acid, or salt. So we recap back. Acid is a substance that dissociate in aqueous solution to produce H plus ion. Whereas base here, substance that dissociate in aqueous solution to produce hydroxide ion. So now we move to HI. HI. So when dissociate in water, so it can form H3O plus and I minus. Okay, so meaning that HI, it will dissociate to become I minus, and the H plus is attached to the oxygen of H2O because of H2O have two lone pair here. Alright, so because it can form H3O plus, so therefore HI is acid. Alright, next, N2H4. Okay, so for N2H4, when dissociate in water, okay, actually this one is okay, so weak base, Alright, so structure of NH2, we have two center atom, nitrogen. Okay, and then on the nitrogen atom, we have lone pair. Okay, because of that, N2H4, so it can accept a proton from H2O. So therefore, it become N2H5 plus. Plus because accept a proton. Okay, plus OH minus. So it accept a proton from H2O. So because it can form OH minus, so this is a base. Calcium nitrate. So calcium nitrate, okay, when it dissociate, it will become Ca plus NO3 minus. Okay, so 2NO3 minus. And it cannot form H3O plus or OH minus. So therefore, it is a salt. Okay, now BaOH. Okay, when it dissociate, it can form Ba plus OH minus, 2OH minus. Therefore, because it can form OH minus, so beryllium hydroxide is a base. Alright, next example. Okay, so write a conjugate base for this following acid. Okay, so we recap back. What is conjugate base? Species formed when an acid donate proton. Alright, so meaning that donate, you have to remove one of the H. So for this one, H2SO4, donate one H plus. So it become HSO4 and the charge would become negative because donate a proton. Okay, HS minus, donate H plus and it will become S2 minus. Okay, NH4 plus, donate a proton, so it will become NH3, neutral. Okay, HClO plus, when donate a proton, so it becomes ClO4 minus. Okay, next example, write a conjugate acid for the following bases. So conjugate acid here, we can define that species form when a base accept proton. So must accept a proton. So NH3 accept a proton, so it become NH4 plus. Right, HCO3 minus accept a proton, it become H2CO3. Okay, so meaning that we have H plus CO3 minus. Okay, HCO3 minus. So since the positive and negative charge is equal, so that's why it becomes H2CO3 without charge, become neutral. Alright, so HPO4, we have H plus, and then we have HPO4 2 minus. Okay, so the charge here is not equal. Alright, so positive 1 plus negative 2. So that's why it become H2PO4 minus. Still have charge. Okay. Alright, next Cn minus, H plus, react with Cn minus. So this one is equal. So equal charge, positive and negative. So now it becomes HCN. Alright, next. Identify the conjugate acid base pairs for the following reaction. Right, so we have recap back conjugate acid species that is formed when a base accept proton. Okay, whereas for the conjugate base is refer to the acid that donate proton. Okay, alright, next we take a look at this one. First of all, what you can do. Right, so you have to find out the pair. So NH2 minus, pair it with NH3. Okay, and then we we compare. So from NH2 minus, now it become NH3. So which means NH2 minus accept a proton. So this is a base. And the product form is conjugate acid. Okay. And then the other pair is referred to the H2O, pair it with OH minus. So we can see that H2O has donate a proton and become OH minus. So because donate a proton, H2O is an acid. Whereas for the product form, OH minus is referred to the conjugate base. Okay, now we move to the second question. Right, so first we have to pair it. Right, so NH4 plus compare with NH3, we can see that NH4 plus has donate a proton. So therefore donate a proton, so this is acid. And the product form NH3 is conjugate base. Okay, Cn minus compare with HCN, which means Cn minus accept a proton. So therefore this is a base. And the product form is conjugate acid. Alright, next, number 3. So first of all, you have to find out the pairing. Pair it. Now we compare. HClO4 becomes ClO4 minus. So meaning that HClO4 donate a proton and become ClO4 minus. So this is acid. And the product form is conjugate base. Alright, next, N2H4. So become NH2H5 plus, which means N2H4 accept a proton. So therefore this is a base. And the product form is conjugate acid. Okay. Alright, next, identify Lewis acid, Lewis base for the following compound. So we take a look. Lewis acid, substance that can accept a pair of electrons. Whereas for the base, donates a pair of electrons. So now we take a look at AlCl3. So this is incomplete octet. So meaning that it can accept a pair of electrons. So this is acid. Lewis acid. Okay, next Br minus have rich in electron, more electron. So it can donate. So this is Lewis base. Okay, NH3 have lone pair on nitrogen atom. So electron rich species. So this is Lewis base. Alright, next. Fe3 plus electron deficient species, less electron, can accept an electron, a pair of electrons. So this is Lewis acid. Okay, H2S. H2S, actually it has 2 lone pair on the S atom. So therefore it can react as Lewis base, can donate a pair of electron. Okay, BCl3. So this is under incomplete octet. So this is Lewis acid. Okay. Alright, so that's all for today. We continue in the next lesson. Thank you.